Hello everyone, I'm Yufei Niu. Today I will walk you through a machine learning project focusing on predicting whether patients are at risk of developing cirrhosis using machine learning techniques. We implemented two modeling approaches, a decision tree classifier and a Picard-based low-code classifier. I will break it down into three key areas. First is the data processing steps, and second is why the chosen models are suitable for the dataset. For the last part, insights from the results and what they mean for real-world applications. Here's the business background and the libraries required in this project, the data dictionary, and the EDA process. Let's get started with the data preprocessing. So the first part is data preprocessing. In this section, we will deal with the essential data preprocessing steps required to prepare the dataset for building a classification model. This process involves handling missing values, encoding categorical features, managing skewness and outliers, and scaling numerical variables. First, handling missing values. Missing values in the dataset were replaced with suitable defaults to ensure model stability. For quantitative features, missing values were filled with zeros to maintain numerical consistency. Similarly, categorical variables such as spiders also had missing values filled with zero, indicating absence. This step ensures that no valuable data is discarded and the dataset remains intact for modeling. And for the second part, encoding the targeting variable. The target variable's stage represents the histologic stage of cirrhosis 1 to 4. To simplify classification, stages were grouped into binary values. 0 for non-cirrhosis stages 1, 2, and 3, and 1 for cirrhosis, which is stage 4. This binary encoding enables us to predict the presence of cirrhosis effectively. And third part for the skewness. Many numerical features exhibit skewed distributions, which could impact model performance. To address this, log transformation was applied to feature with skewness greater than 1. This reduces extreme values and normalizes the distribution. And for the outlier handling, outliers in numerical variables were identified using Turkey's rule. Based on the IQR, to mitigate the impact, a technique called winsorization was applied. This method limits extreme values will remain a routine in the dataset's overall distribution in this part. And this is a winsorization. And next part, to incorporate categorical variables into the model, one-hot encoding was applied. This converts each category into binary variables, ensuring the model understands the categorical relationships. And for the final step, dataset balance and correlation analysis. The dataset was evaluated for class imbalance, revealing that approximately 34.4% of the sample represent cirrhosis cases. A correlation heat map was generated to identify relationships between features, highlighting variables like bilirubin and albumin as strong indicators of disease. And you can see the correlation of all the features here. For this part, I will explain why the chosen models are suitable for the datasets. To classify patients into cirrhosis and or non-cirrhosis categories, we implemented two modeling approaches, a decision tree classifier and a Picard-based low-code classifier. In terms of implementation, the dataset was split into training and test sets in an 80 and 20 ratio in this code. And for the decision tree classifier, we set up a pipeline that included three key components: standard, scalar, smooth, and the decision tree classifier itself. The standardized scalar was used to standardize the feature ranges, ensuring that features with large magnitudes do not dominate the model training process. Modes address the issue of class imbalance by oversampling the minority class, helping the model better learn patterns from underrepresented data points. Finally, the decision tree classifier serves as the primary algorithm for prediction. Here is the code pipeline. And scaling and smooth were applied only to the training data to prevent data leakage. The pipeline were then trained on the processed training data with this code. And finally, we evaluate the model on the test set with this part of code. And here is the results. The model achieved an accuracy of 64.29% with the confusion matrix. Will this model provide a baseline? Its performance could be improved further with hyperparameter tuning. Next, we explored a low-code approach using PyCaret. We began by using the setup function to handle pre-processing tasks such as normalization and balancing the dataset using smooth in this code. And the compare models function was used to automatically benchmark multiple classifiers and identify the best performance model. The code here. And the extra tree classifiers emerged as the best performance model based on metrics such as accuracy and F1 score. To improve its performance further, the model was fine-tuned. With this code. And finally, predictions were made using the test site with this code. And we can see the results here. The extra tree classifiers achieved an accuracy of 75.77%, significantly outperforming the decision tree classifiers. The use of PyCaret also reduced the time and effort required for manual feature engineering and hyperparameter tuning. This is the PyCaret based low coding part for the classification. From the results, several key insights emerged. Feature importance analysis revealed that variables such as bilirubin, albumin, and prothrombin were the most significant predictors of cirrhosis. These findings align with clinical knowledge about liver function, confirming the model's ability to identify medically relevant features. Furthermore, the use of smooth greatly improved recall for the minority class, making the models more effective at identifying high-risk patients. Comparing with two approaches, the PyCaret workflow proved to be not only more accurate, but also more efficient. Its automation capabilities make it particularly valuable for large-scale healthcare applications. In terms of real-world implications, this model can assist healthcare providers in early diagnosis and management of cirrhosis. By identifying high-risk patients, healthcare professionals can prioritize resources and interventions, improving patients' outcomes. This modeling exercise demonstrated that the value of combining domain knowledge with machine learning techniques to address healthcare challenges effectively. Thank you very much. This is my M1 assignment of machine learning courses. Thank you.